Lesson 7 Project Video Help. So as Farmer Frank continues working on his farm, he finds a box for holding some of his farming tools. The box with no top is made from a 10-inch by 14-inch piece of metal by cutting identical squares from each corner and turning up the sides. The volume of this box can be modeled by the polynomial v of x equals 4x cubed minus 48x squared plus 140x. So we're going to use that information in order to solve a few problems. So the flattened box is shown in the image. Note that each corner has an identical square with measures of x inches cut out, represented by the dotted lines. What are the length and width of the box? So we want to know what the length and the width of the box are when it's folded up. So we have that 14 inches is the length of the whole side when it's not folded up. So when it's folded up, we're going to be missing this piece here, and we're going to be missing this piece here because those sides are getting cut out. This whole box here, this whole box here, this whole dotted box, and this whole dotted box are all getting cut out, and the sides are getting folded up to create a rectangle. If you need a more visual representation, you can go ahead, take a piece of your paper, cut out the four corners, and then fold the sides up into a box. So we need to know what the length of our box is. So we have that the full length is 14. But what is it that we're taking out? Well, we're taking out an x on the right, and we're taking out an x on the left. So that means that we're taking out, we have our 14, take out an x, take out an x. So if we combine the like terms, we get 14 minus 2x. That gives us the length of our box. Next, we want to know what our width is. So it's a similar thing to the length with our width, except our width, we have that it starts out with 10. So our whole length here is 10. But then we're cutting out from the top part here, we're cutting out a value of x, and from the bottom part here, we're cutting out a value of x. So that means that we have our full length is 10 minus an x minus an x, which gives us 10 minus 2x as our width. So our length is 14 minus 2x, our width is 10 minus 2x. What is the GCF of the terms in the polynomial representing the volume of the box? V of x equals 4x cubed minus 48x squared plus 140x. We need to know our GCF. Remember that the GCF is the greatest common factor. So if we look, we need to see what each of these terms has in common. Well, if you look right away, they each have an x. So that means part of our GCF is an x. Now we know 4, 48, and 140. Do they all have a number in common? Well, you can easily tell that they all have a 2 in common since they're all an even number. But the next highest thing we have here is we have a 4 at the beginning. Are they all divisible by 4? Well, if we take 48 and we divide by 4, we're going to end up with a 12. If you take 140 and divide by 4, we end up with 35. So that means that since we don't have any decimals or fractions, that we ended up with that they all have a 4 in common. So that means our GCF is 4x. Refer to the previous question. When you factor out the GCF from the terms of v of x, what is the remainder adding factor? So we have 4x was our GCF. Our v of x equation that we had is that v of x equals 4x cubed minus 48x squared plus 140x. So we're going to take each of these terms, divide it by 4x to get what our polynomial is when we factor out the 4x. So if we take 4x cubed divided by 4x, we're left with x squared minus 48 divided by 4 was 12. X squared over x gives us an x, plus 140 divided by 4 was 35. X divided by x is just 1, so we don't write anything. So The remaining factor is x squared minus 12x plus 35 when we factor out our GCF. Okay. Refer to the previous 3 questions. Based on your answers to the previous 3 questions, as well as your knowledge of factoring, what are some possible factorizations of v of x? Well, we have that when we just on the last one, we took our 4 of x, our GCF, and we factored it out, and we were left with 4x times x squared minus 12x plus 35. So that would be one possible factor. Another factor would be, well, what if we factor our quadratic here? So we need 2 numbers that multiply to 35, add to negative 12. Well, I know my factors of 35 are 1, 5, 7, and 35. Well, I know if I add 35 and 1 in any way, I don't get a 12. But if I add 5 and 7, I get 12. But I need a negative 12, so that means I need both 5 and 7 to be negative. And if I have 5 and 7 both be negative, then when I multiply, I get a positive 35. So this means that we have an x minus 7 and an x minus 5. So that's the second way. Now there is one more way. If we refer back to the very beginning, when we got our length and our width, we have that our length was 14 minus 2x. We have that our width was 10 minus 2x. The only thing we're missing when we talk about volume, remember, is length times width times height. So we have a length, we have a width. We just need a height. Well, if we took a look at our box, our height that we were cutting out of each corner was x. Because when we fold it up, that becomes our height of our box. So our height of our box is just x. So that is our third way of factoring this. So all 3 of these are possible factorizations of v of x. Hope that this helps with your project 7. If you have questions, please contact me and I will assist you.